In this example, we're going to solve a non-right angle triangle using both the sine and the cosine rules. So we're giving a pole AC. It's standing on a hill that's inclined at an angle of 8 degrees. Down the hill, 20 meters from the base C, there is a support wire attached to the ground at B. If the wire makes an angle of 12 degrees with the hill, we're asked to calculate the height of the pole H and the length of the wire. Is it possible to work out all the angles within the triangle ABC? Let's work out the angle at A, for instance. I'm just going to sketch out this triangle again on the page here. We know it has a height H. We also know that this triangle has an angle of 12 degrees within it. Now look at the 8 degrees. If we imagine a horizontal line coming out from B, we could create a right angle triangle. We know that there's an 8 degrees and a 12 degrees. So adding these together, we can see that there's a 20-degree angle in the right angle triangle. Therefore, the top angle at A must be 70 degrees, since 20 and 70 and 90 add up to 180. So we can see that the angle at A in our given diagram must be 70 degrees. Now we know in fact all the angles. The angle at C must be 98 degrees, but we know two of the angles, and we're given in the question also that the distance between B and C is 20 meters. So to solve this question, where we're given two sides and two angles across from the sides, we're going to use the sine rule. We want to figure out what H is, so we let H be our A, and our angle at A is going to be 12 degrees. So H over sine 12 degrees must be the other side, the 20, over the angle across from that, so sine 70. Multiplying across by sine 12 degrees, we see that H is equal to 20 sine 12 divided by sine 70. So we type this directly into the calculator, and we can see that H to 2 decimal places is 4.43 meters. The second question is asking us to find the distance AB. Let's call this X in the diagram for short. We know pretty much all the other information about this triangle. We know the two other sides, the 20 and the 4.43, and we know all three of the angles. We have a choice here. We could use the sine rule or the cosine rule because we have so much information. I'm going to use the cosine rule. So the cosine rule says that x squared is equal to 20 squared plus 4.43 to be squared minus 2 times these two sides multiplied by each other, 20 by 4.43, by cos of the angle that's opposite the x, so that's cos of 98 degrees. So I put all this into the calculator to work out what x squared is, and we can see that x squared to 3 decimal places is 444.286. So I square root both sides, and this will tell us that x, which is also the distance AB that we want to find out, is equal to 2 decimal places this time, 21.07 meters. So we had a choice which to use in this question, and I chose to use the cosine rule.